These are the notes for the definite integral introduction. Um, we've kind of already talked about some of these parts. There's just some other areas as well. The first one is the definition of the definite integral as the area of a region. The top part of this page is sort of the theory behind the whole thing, but not as important as understanding um, definite integral. So if it's continuous and non-negative, then the area of the bound by the graph of f, the x-axis and the vertical axis. So we got to be above the x-axis and on a region that's continuous, and we can find the area. So we have this picture here uh, of a function, and so it says that we're supposed to find the value of each of the following definite integrals. So we're notice this is not all above the x-axis. So anything below the x-axis is negative. So the area is the area, but the value of the integral will be negative. So if we're looking at the integral from -4 to +2, to find the value of that integral, if we don't have a function, we just need to find the area of the section. And so usually you can just section this thing off into parts and find the areas of the individual parts. So right here we have a trapezoid that has a base of 3 and 2, and then the height would be 3. So the area of that region would be 1/2 the average of the base. That's how we're finding average of the bases times the height. So that's 5 halves. That's 15 halves. So this section right here is 15 halves. This triangle is 1/2. So the area there is 1 because 1/2 base times height. The area here, this is a 2/2 triangle, so that's 4. Half of that is 2. And I'm going to go ahead and do this last triangle because we're probably going to need to use it. This is 1/2, so the area is 1. So if we're going the integral from -4 to 2, we have -15 halves, -1, and +2. So that's -15 halves plus 1, which is 2 halves. So that would be -13 halves. The integral from 0 to 3 would be going left to right, +2 and -1. That value would be 1. If we were finding the area, we'd think about it absolute value, but we're finding the value of the integral. From -1 to 1, the little triangle right there would be 1. So that would be -1 plus 1, which is 0. So those are 3 values you can do using that graph. There are a couple definitions about integrals, sort of going in a backwards order, but I wanted you to see the picture. I can't see that print very well. The integral from a to a is 0, and it seems obvious. If you're not going anywhere, you have the value is 0, but that's an important property that's used. And this one also, if you switch the boundaries, if you go from right to left instead of from left to right, you get the opposite area. So the integral from -1 to 2 would be the opposite of the integral from 2 to -1. So if you flip the boundaries, you flip the area. And then we have some other fairly basic properties that are similar to derivatives. You can take a constant and move it out front, because b minus a is just the area of that space. You can separate integrals into sums and differences of integrals. You could write that as plus or minus. And this is also a constant multiplier rule. Constant times a function. The constant goes out front. These two kind of go together. The reason this one is c b minus a is because when you're left with just a dx, the integral would be c times x from B to A. And so when you plug that in, you get B minus A. So kind of basic properties. Notice there is no product rule and there is no quotient rule. So you can't multiply or divide integrals and stay with the properties. That's the same as true for derivatives, since they are the same. So often you follow up with some derivatives that we don't know the function, or the integrals we don't know the function. So it's just asking us to use our properties. So f of x plus g of x would be the integral of f plus the integral of g. And the integral of f is 10. The integral of g is -2, so that would be 8. This one is using our constant multiplier. So 2 integral of f minus 3 integral of g. And we're just substituting in values. So 2 times 10 minus 3 times -2. A lot of just arithmetic there. Integral of 6. Now notice we can rewrite that with the constant multiplier rule, but the bounds switched. So we're going to use the opposite. If we want to switch the bounds back so we can use our -2, we're really taking the opposite of -2. So that's +2 for this integral. So the value would be 12. And this one, we can't do it because we can't do a quotient rule. So don't force your rules in there that don't exist. Okay, a few more examples down here. Again, you want to break it up, see what you have. We have -2 to 4 for a couple of these. So we're going to break this up into two integrals. -2 to 4 of f, -2 to 4 of 4. So -2 to 4 of f is -6, but we can just do the integral here. The integral of 4 is 4x. And then you're going to plug in the 4 and the -2. Or you can use your multiplier rule, which says the integral could be written like this: 4 integral of -2 to 4 dx. And that's just going to be 4 times b minus a. So b minus a. There's your, it goes back up to this property, but we've already talked a little bit about how to do definite integrals if you're up to speed on what we're covering. So that's 6. And this one can break into 3 integral -2 to 4 of g plus -2 to 4 of x. Your dx is in there. Again, you need this one. You can integrate. This one we already know the value. G of x from -2 to 4 is 4. And then we can integrate x, raise it by 1, and plug in our numbers. So we have 12 plus 1/2 4 squared minus -2 squared. So 1/2 16 minus 4. That's 12. 1/2 of 12 is 6. 12 plus 6, 18. And you get your properties there.